Good morning, ladies and gentlemen. What we're going to be doing today, we are going to be working on scientific notation. Now, we've worked a little bit with scientific notation, but we're going to do a lecture on scientific notation and a worksheet because I noticed that some of us are struggling with how to put numbers into calculators and what numbers are supposed to look like. So, what I'd like to do is start us off with a couple of questions just to see where we stand. And so let's take a look. All right. Oh, I highly suggest you take out a calculator that you want, or that you go and open up this Desmos calculator that I have on my homepage, so that you can use it and type along with me if you need to. So this is going to be a math lesson, which I know people are like, "Oh my gosh, it's horrible." Well, you're going to find out it's really just very straightforward. All right. So number one, ladies and gentlemen, this is the number 26. This is the number 26. My question for you is, where does the decimal go for the number 26? Is the decimal going to go at location A, location B, or location C with the number 26? Good. So I can see that you all wrote down that the decimal for the number 26 will go at location C. So here's the number 26, right? And the decimal would go there even though we don't show it. If we put the decimal at location A, which would be right here, it would be 0.26, right? If we put it at location B, it would be 2.6, and location C is the number 26, all right? So we can see that the number 26, the decimal, is going to go after the 6, all right? So let's take a look. 10 to the 2, ladies and gentlemen, equals what number? 10 squared equals what number? That's right. 10 squared equals the number 100. Now, there's lots of ways to do this, but this little 2 means take the number 2 times. So it's going to be 10 times 10 equals 100. If there was a little 3 there, then it would be 1,000. So let's take a quick look at how we could work this out. There's a bunch of ways to do it. Okay. So you would say, I have 10, and you could take your 1, because there's 1, and then this says take 2 zeros. So 1, there's your decimal place, and then that little 2 can mean take 2 zeros. 1, 2, which means your new decimal place goes there. You fill everything in with zeros, and now the number is 100. And yes, that's where the decimal point goes. You don't have to show me, because at this juncture, being a high school student, you should know the decimal always is going to come after the number unless shown. Okay, let's take a look at the next example. 10 to the minus 2 equals what number, ladies and gentlemen? That's right. 10 to the minus 2, ladies and gentlemen, is going to equal 0.01. We could also write 0.01, and that would be like a little placeholder. These zeros in front, all they are is placeholders to our 0. So how could we work this number out? You would look and you could say, well, we have the number 1, and there's our decimal place. And then this one says, we're going to back our decimal place up 2 times, right? And we're going to have a smaller number, and we're going to back it up 2 times. There's 1 place, and there's 2 place. The new decimal place is going to go right there. We're going to fill zeros in everywhere else, where the new number equals 0.01, or 100th. This number is called 100th. 10 squared equals 100. 10 to the minus 2 equals 100th. Notice they both have a 2, and they're both 100. Just one's a th on the end, hundredths. All right, so let's take a look. Now let's take a look at decimals. Some kids get really afraid of decimals. I'm going to try to help you out a little bit. All right, some kids are just like, oh my gosh, I don't know what to do with numbers. Fantastic. Let's take the number 3 times 5 very quickly. 3 times 5 equals 15. Well, let's take the number 0.3 times 5. Well, some kids get scared and go, "Oh my God, I don't know how to multiply decimals." Well, a decimal is just a location to let you know what the number is like. This is still 3 times 5 equals 15. Then we just throw the decimal. We have one decimal place in there, so we're gonna move one decimal place. We'd move over one decimal place, so our number would be 1.5. It's a very straightforward system. So I'm gonna ask, try not to be afraid of decimals. If you are, we're gonna get over that fear. All right. So, what is a decimal, ladies and gentlemen? Well, a decimal is a number that's less than 1. So, here, this is the big zone right here in chemistry. That's the number 1. All right? And the number 1 sits right here. Notice that there's a 0 in the ones place. Hopefully, you know what that means. If you don't, well, go look it up. And there is no 1 there, which means this number must be less than 1. Now, there's no negative sign here, which means the number is between 0 and 1. Most numbers we work with in chemistry, a lot of them, are going to be between 0 and 1. All right? If the number is bigger than 1, you could say, well, where would the number, here's the number 1.5, right? And that means you have 1 and then half of another number, right? This letter I here represents, I guess, all numbers between 1.75 and 1,000. And the letter J represents all numbers over 1,000. So we're going to do some little tests and quizzes, and we're going to figure out what we know about numbers. All right? So again, each one of these letters would say, like B would be a number between 0 and 0.25. D would be a number between 0.5 and 0.75. I would be anywhere from 1.75 all the way to 1,000, and J would be over 1,000. So we're going to take a look. We're going to work with some exponents. Okay? Now, we just did this one right here. So this number is 10 squared. 10 squared, or 10 to the second power, means 10 times 10. What's 10 times 10? Which is going to equal 100. All right? Or you could write down 1. There's our decimal place, and move the zeros 2 times. So this says 2 0 decimal places. So there's 0, 0, new decimal place. What would 10 to the 3 be? 10 cubed, or 10 to the third power, would be 10 3 times. 10 times 10 times 10. So that's basically going to add another 10. So now we have 10 times 10 times 10, which is 100 times 10, which is going to be 1,000. Or we take the number 1 and add 3 zeros to it. Right? We move our decimal place 3 times. And so our new number is 1,000. And the same rule will apply here. 10 to the fifth power means you have a 1 with 5 zeros after it. There's 1, 2, 3, 4, 5. There's our 5 decimal places. And we fill all those in with zeros, where in this case, we would have the number 100,000. Okay, so what would be 5 times 10 squared? Well, 10 squared equals 100. So what is 5 times 100? 5 times 100 equals 500. All right, let's try the next one. This one says 7 times 10 cubed. What would the answer be to 7 times 10 cubed? That's right. The answer would be 7,000, because I'm going to take my decimal place, I'm going to move it 3 times, and that happens to just be where the comma is. It'd be 7,000. Let's try this next one. This is a tough one. 8 times 10 to the fifth. Remember, 10 to the fifth is the same as 100,000. So what would our answer be for 8 times 10 to the fifth? That's right. It would be 800,000. So there's our 8. And we're going to move 5 zeros. 3, 4, 5. 1, 2, 3, 4, 5. And our comma would be right in there. So our number would be 800,000. All right, good job, ladies and gentlemen. Hopefully you're getting this little lesson on what it means to have exponents. All right, now, whoops, let me put all that back. Let me put that back. There we go. Let me bring this down a little bit. So here's my question. 10 squared, the number 100, would be which one of these letters? Where would the number 10 squared or 100 fall on this number line, ladies and gentlemen? So on this number line, which letter would be the number 100? That's right. It would be the letter I because it's going to fall between 1.75 and 1,000. Let's take a look at this one. Let's try 10 to the fifth power. Where would the number 10 to the fifth power lie? What letter would we have at 10 to the fifth power? That's right, ladies and gentlemen. We do have J because the number 800,000 is much bigger than the number 1,000. Okay, does everybody see how that works? We're going to play this game in just a second. All right, so let's keep going. Okay, so now let's take a look here. We have our number line, and here we have our numbers here. So 10 to the minus 2 power. What is that number? Well, remember, we're going to take a 1. There's our decimal place because the decimal place is going to be there for the number 1. Then we're going to move this. This means it's a small number. Doesn't mean it's a decimal place. It means it's a small number. And we're going to move this back 1, 2. So our new number is going to be 0.01. All right. Where on the number line would 0.01 fall, ladies and gentlemen? Where on the number line would 0.01 fall? Would it be the letter A, which is a little bit smaller than 0? Would it be B, which is in between 0 and 0.25? C, D, E? Where would the number 0.01 fall? That's right, ladies and gentlemen. It would fall at B, because if this is 0.25 and 0.01 is right there, super close to the number 0. Let's take a look at 10 to the minus 3. What would the number be for 10 to the minus 3? That's right, ladies and gentlemen. It's going to be 0.001. How did we get that? Well, we have the number 1. And that negative sign means it's a small number. And we're going to back it up 1, 2, 3 times. There's our new decimal place. Fill everything in the zeros. What letter would this fall under, ladies and gentlemen? Where would the number 0.001 be? That's right. It's going to be between the 0 and the 0.25. This is a number. It's not a negative number. It's between 0 and 0.25. It's 0.001. It would be like right next to the 0. It would be super duper close. All right, let's take a look at the next one. 10 to the minus 5. What would the answer be for 10 to the minus 5? That's right, ladies and gentlemen. It's going to be 0.00001. How did we get that? Because we have the number 1. That's what the number 1 looks like. And then we're going to count back 5 times. Hope I just did that right. I'm talking while I'm moving. 1, 2, 3, 4, 5. Yep. That's where the new decimal place goes. Everything else fills in with a 0. All right. And there it is. So what would the answer be to 5 times 10 to the minus 2? Well, you do the same thing that we would do up here. Here, we would have the number 5. There's our decimal place. And then we're going to move it back 2 times. 1, 2. There's our new decimal place. That's what it looks like. So this number would be 0.05. What would the answer be to 7 times 10 to the minus 3? What would we have for our answer? That's right. We would have 0.007. How do we get that? Well, we have the number 7, and there's our decimal place normally. We're going to back that decimal place up 3 times, right? And there we go. Ladies and gentlemen, what letter would the number 0.007 be? Would it be A, B, C, D? Where would the number 0.007 be? I kind of feel like I gave you the answer because I said, where would the number be? It is B, ladies and gentlemen. All right. So the number is right here. This would be 0.007, about right there, really close to 0. All right. And then this one here would be the same. It'd be 5 numbers out. So it'd be 0.00008. Very similar to this one here. They would have the 8 with the decimal place and moving it over 5 times. Hopefully you guys have understood this. If you don't, I suggest you go over it again, but you probably already know this information because you've already passed an algebra class. So now what we're going to do is we're going to practice writing, ladies and gentlemen, in scientific notation. All right, so let's practice writing in scientific notation. This is the number 567. Well, how are we going to write the number in scientific notation? Remember, the number scientific notation is like 7 times 10 to the negative 5 or whatever. These numbers are all scientific notation up here. All right. So how would we write this number? Well, we would say that 500 is a big number. All right. Where does 500 lie? Well, if we take a look at our number line up here, ladies and gentlemen, let me copy this and bring it down for us. Notice the number 567 falls up here in the big zone. Everything from here on out pretty much is the big zone. Those are big numbers, all right? So the number 567 is a big number. The decimal place isn't shown, but it's right there. When writing scientific notation, you only get one number in front of the decimal, and then other numbers after the decimal, and then times 10 to the whatever power, okay? So you get one number and then the decimal. You may not write this as 123.4 times 10 to some exponent. I want you writing it one number and then the decimal. I highly suggest you pay attention to that right there. So the question is, how many numbers do you write in front of the first digit, in front of the, let me say it again, how many numbers get to go in front of the decimal place, ladies and gentlemen, when using scientific notation? That's right, just one number. So how do we write this number in scientific notation? Well, we're going to take the decimal place, and we have to put the new decimal place, ladies and gentlemen, has to be right here. So that's where our new decimal place is going to go. Why? Because we only get one decimal place, one number, okay, by the decimal. So this decimal place needs to move over 1, 2 times. And this number is going to be 5.67. Notice that the original number was 567, and this number is not 567. We need to make this number 567. So then we're going to say, well, let's take that and multiply it times 100. And we move the decimal place 2 times. So it's going to be times 10 squared. Okay. So this would be how to write scientific notation. Here's another one. How would we write this number in scientific notation? Well, where would the decimal place go, ladies and gentlemen? Is the decimal place going to go between the 0 and the 1, between the 1 and the 2, or between the 2 and the 3? Where is the decimal place going to go? That's right, ladies and gentlemen. It's going to go between the 1 and the 2. Why? Because you only get one number in front of the decimal place. So there's our decimal. We have to move this decimal over there. We're going to move it 1, 2, 3, 4 times. Now, 1.23. And we moved it 4 times. And now here is the important part. Is this a number bigger than 1 or smaller than 1? Is it one of these big numbers over here, or is it one of these small numbers? This is a small number. It's going to go right next to 0, which means since it's a number smaller than 1, we're going to use a negative sign. So we're going to go 1, 2, 3, 4. So this is going to be 1.23 times 10 to the negative 4, because this is a small number. All right? Small numbers get that negative sign saying it's between 0 and 1. Large numbers just get a regular positive number. Okay? So let's take a look at this next one here. Let me move this screen down a little bit. Here's the number 65 million. Is the number 65 million a really big number or a really small number according to my rules? That's right, it's a really big number. So what kind of exponent are we going to have once we get to the times 10? Are we going to have a positive or a negative exponent? Are we going to have a positive or negative exponent? That's right, we're going to have a positive exponent. So let's play the game. That's where the normal decimal place goes. And we're going to move it to this point right here between the 6 and the 5, because those are, you only want one number to the left of the decimal. There's 1, 2, 3, 4, 5, 6, 7. We just moved the decimal place 7 times, which means our number is going to be 6.5 times 10 to the 7. And that's a big 7 because you're getting into the millions. So let's do one more example. where is the decimal place going to get moved to? Is it going to get moved? Whoops, is it going to get moved between the 0 and the 5, between the 5 and the 7, or between the 7 and the 4? Where are we going to move the decimal place, ladies and gentlemen, in order to make this number? That's right, we're going to move it between the 5 and the 7 because we only want one number at the beginning. We're going to move it 1, 2, 3, 4, 5 times, which means this number is going to be 5.74. Whoops. 5.74 times 10. Is this a big number or a small number? It's a small number. So we're going to put a negative, and I forgot my number already. 1, 2, 3, 4, 5 to the negative 5. And that's how we write scientific notation, ladies and gentlemen. All right, the next thing we're going to do is we're going to convert from scientific notation into normal numbers. Okay, so how are we going to do that one? Well, we are going to take our decimal place, and we're going to get rid of this 10 to the 2. This means move the decimal place 2 times. Now, is this a big number or a small number? Since it's positive, we're going to be making big numbers like 500s, 1000s, not small numbers like 0.0000. So this means move my decimal place 2 times. We're going to move it 2 times. 1, 2, which means my new decimal place is going to go right here at 567. So this number equals 567. Okay, let's take a look at the next one. The next one says 7.52. Since this is a negative exponent, that negative exponent means it's going to be a small number, which means we're going to move the decimal place the other direction. How many times? 5 times. 1, 2, 3, 4, 5. And that's where our decimal would go. We have to fill all these in with zeros. So our new number would be point. And if you want to put a 0 in front, that's fine. But we're going to be worrying about the decimal place. I have 4 zeros after the decimal. 1, 2, 3, 4. And then the number 752. And ladies and gentlemen, that would be how we would work out this decimal right here. And now one last example, ladies and gentlemen. So this example here says 2.35 times 10 to the 7th, which means we're going to move the decimal place 7 times. Is this going to be a big number or a small number? Well, since it's a positive, it's going to be a big number. So we move the decimal place 7 times. I'm going to rewrite my number right here. 2.35. And now I need to move this decimal place 7 times, making this a really big number. 1, 2, 3, 4, 5, 6, 7. The new decimal place is going to go there. I fill all these little hoops in with zeros. It's kind of messy, but we get the gist. So now our new number is 235, 0, 0, 0, 0, 0, 5 zeros. The new decimal place is right there. 1, 2, 3, comma, 1, 2, 3, comma. Our answer would be 23 million. This is how we work on scientific notation. Whoops. All right, so let me scroll down. I think that was it. Oh no, gosh, we're almost done. Forgot, that's right. How to use a calculator, ladies and gentlemen. So this is giving kids some problems. So I'm going to work with you on how to use a calculator. All right, so I do suggest using this Desmos system. I suggest parentheses as well. So this means divided. So we're going to take the number 4.14 times 10 to the 4th divided by that number. So let's work it out here. You ready? So first thing I'm going to do, I'm going to put parentheses. I like working with parentheses. So I'm going to put in 4.13. And then to do times, I have to push the x times 10. I'm going to push to the 4th power. All right. I'm going to go outside the decimal places. And I'm going to push divided by. Whoa, it turned it into a fraction because that's what the fraction line means. The fraction lines mean divide by. Okay. And so now we're going to put brackets again. And we're going to put in the number 6.8 times 10 to the negative 3. Now, how are we going to do a negative sign on our computer? Okay, because we want it to be a negative 3. So there's our 3. Sorry, kids, I deleted that because I did not push the exponent. So it's going to be to the minus 3. So I have to push a to the b. And then what I'm going to do is I'm going to push minus the minus sign, and and then put in 3. And this would be my answer to that would be my answer. So the answer, ladies and gentlemen, would be, let me move these things over. Sorry if my screen's getting a little funky. Okay. My answer would be, I'll put it underneath it. It's going to be 6073529. Now, what does that mean to us? Well, and then it has 0.412. That's our whole answer. So what we want to do, ladies and gentlemen, is take that number and put it into scientific notation. So how would we do that? Well, you would say, well, and when we do scientific notation, I told you I always want 2 numbers after the decimal place. So we're going to move our decimal here, okay? And then we're going to move it how many times? 1, 2, 3, 4, 5, 6. So our answer, ladies and gentlemen, is going to be, if we look here, the answer to this is going to be 6.07, okay, times 10 to the what? So we have 1, 2, 3, 4, 5, 6 times 10 to the 6th power. That is our answer, all right? Again, we only want to keep 2 numbers after the decimal place in my class. So you have to take this yourself and put it in scientific notation. I'm betting that there is a function, what if I go to settings, and I can change it into scientific notation. All right, so let's see, function. I wonder if I can put it in scientific notation. Main. I don't see it, but I will find that for you. And maybe you can't do it. Maybe we're always going to have to, put it in scientific notation ourselves, which is great practice. All right, so let's take a look at this next problem here, ladies and gentlemen. Okay, the next problem here says you have 7.04, and let's clear this out. Okay, so we're going to put in 7.04, and we'll put parentheses. Sorry, I told you to always put parentheses. All right, we'll go back in there. 7.04 times 10 to the 5th power. And it's the negative 5th power. So I'm going to push my exponent button, which is right here. And I'm going to push negative 5. And I'm going to come outside my exponents, and then I'm going to multiply. So then I'm going to go times. I'm going to put another set of parentheses. I'm going to go inside my parentheses and type in 5.33 times 10. And I want to go to the negative 3rd power again. So I'm going to push my exponent button. I'm going to push the minus key and the 3, and that's going to say to the minus 3. So here's our, oh, look at this. It put it in scientific notation for us. Thank you so much. This says 3.75 times 10 to the minus 7. So that's going to be our answer. And we would write down 3.75 times 10 to the negative 7th power. Okay. Lastly, let's look at how to put this into our calculator. Kids are struggling on it. I'm going to show you this again. All right. When we're working with fractions, ladies and gentlemen, okay, these are fractions. This is a number over 1. That's a number over another number. The numbers on the top, we're going to multiply together. The numbers on the bottom, we're going to divide. All right. So when we have this written out, this is going to say 1.44 times 10 to the negative 8th power times, well, people are like, what? But 8.33 times 10 to the 27, all divided by 7.83 times 10 to the negative 16. All right? Mr. P, what if there was a number here? Oh my gosh, that's a great question. That's just what I was about to do. So now let's take this number here. All right? And let's put it here. Let's change it up a little bit. Whoops. Let's undo that. Let's use this number. I don't change my formatting. Okay. So we have this number here. Let's change that to the positive, 11th power. And we'll take away the 7.38. We'll turn it to something else. We'll make it 5.46. Now what happens here? Well, This means we're going to take all the numbers on the top and we're going to multiply all the numbers on the top together. So all these numbers get multiplied together. And we're going to divide them by all the numbers on the bottom. They get multiplied together. All right? So, but in our calculator, it's going to look like this over here. So let's look and see what it's going to look like. We're going to put in 1.44 times 10 to the negative 8. And I do want to be in parentheses. My apologies for not having it in parentheses already, right? And then we're going to divide it by, okay? We're going to divide by, am I recording? Yes. We're going to divide by 5.46, whoops, 5.46 times 10 to the negative 11. Whoops, yeah, times 10. And then we have to go to the exponent to the 11th power. So at this point, this is what our number is, but we have more to do. So how are we going to put this in the calculator? Well, lots of ways to put it in the calculator. We can go back up to the top. We can put and this is just one of them many ways, and just put 8.33 times 10 to the 27th power. Close our parentheses, right? Because all the numbers on the top get multiplied, then all the numbers on the bottom get multiplied. And I'll do the same thing. 7.83 times 10 to the 16th power, or negative 16th power. There's a minus sign there. Minus 16th power. And now there's our answer. Our answer is going to be I can put it in right here. Our answer is going to be 2.81. Mr. P, how come 81? Because the 5 is going to round that 0 to a 1. And I only want two numbers after the decimal place, times 10 to the 23rd power. Okay, and that is our answer. So ladies and gentlemen, hopefully this was useful. Hopefully it wasn't too long, but we really need to practice this. So I'm giving you a handout today on practicing multiplying numbers, and then there's also going to be some converting. All right, enjoy. If you have any questions, I'll be sitting right here. Thank you.